So geometry lesson 28, we're going to be talking about triangle congruence using side angle side. We've already talked about proving two triangles are congruent using side, 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 meaning that if I have three sides of a triangle congruent to three corresponding sides of another triangle, then we can prove that those two triangles are congruent. But there's multiple methods for proving two triangles being congruent or multiple triangles being congruent. Next one on the list is side angle side. As we get further and further into it, we'll find things like angle angle side, angle 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 side, angle side angle. Basically any three angles and a side in no matter what order is going to prove that two triangles are congruent. The commonality, the one thing that we have to have without a doubt in order to prove that two triangles are congruent is that we have to have at least one side. If I only have three angles, all I've proven is that those two triangles are similar, but I have to have one side. In this case, we're using two sides. So sides and angles of polygons have special relationships to each other. The angle formed by two adjacent sides, okay, two adjacent sides of a triangle are two sides of a triangle that meet at a vertex. Okay, does that make sense? So when you know what we mean whenever we say adjacent sides, right, Jose? Okay. All right, so the angle formed by two adjacent sides of a polygon is called an included angle, which means if I'm talking about this side and this side, the included angle is here. It's between them. It's where they meet at. Does that make sense? Okay. So if I had another triangle, okay, it may not necessarily, it could be flipped around so that I'm looking at this. Okay, but if this side is congruent to this side, my two tick marks is congruent to my two tick marks, then the angle that is between them, if those things are congruent, then I can prove using side angle side that those two triangles are congruent to each other. The common side of two consecutive angles of a polygon is called the included side. So when we start looking at things like angle side angle, all right, if I have an angle here and an angle here, that is the included side. Okay, so when we start using things in order and we say angle side angle or side angle side, it literally has to work out in that order. For example, this is not an example of side angle side. Okay? And, this would be angle side side, right? That's how I would go around it. If the acronym ever causes me to cuss, it's not a thing that we can. Okay? So this is not, it has to be included. It has to be between those things. Okay, do we understand included? Okay, all right, great. Okay, so we should understand included angles and included sides. So what we should have learned back in lesson 25, which really wasn't that long ago, is that we can prove two triangles are congruent using side, side, side triangle congruency. This lesson is looking at another way to prove that these triangles are congruent, uses the two sides and the included angle of those two sides. So basically, this just goes in and it states again what I've already stated. So you can read that. It's not going to add anything to it. All right, but the triangle congruence postulates and theorems will be used as justification in proofs. So if they show me two triangles and they give me maybe one piece of information and I can infer other things, but the proof wants me to prove that these two triangles are congruent, one of my last statements might be these two triangles are congruent using the side angle side congruency postulate. So if I know that I can use side angle side, what all of this does is imagine a mathematical toolbox, right? And you can go to a hardware store and buy a toolbox, right? But if you go to a job site and all you bring with you is a toolbox, are you going to be able to do much with the toolbox? Right? The toolbox is good for carrying tools, right? the toolbox is really not even the most expensive thing, okay? But at some point, typically speaking, the more tools that you have, the more jobs you can do, right? But you have to use the right tool for the right job. Okay, so a lot of what you are learning or have learned in math up to this point has been the process of putting tools in the toolbox. Now, granted, any tool can be a hammer, but at the end of the day, a hammer can't be a Phillips head screwdriver, right? It won't work, right? There's sometimes you need a wrench, right? There's sometimes you need a screwdriver. There's sometimes you need wire cutters. And listen, a hammer can't be wire cutters, okay? So in what you've learned up to this point, now you're trying to look through the toolbox and see which things in here can I use to do the job that needs to be done. And that's what proofs are. Proofs are a job that needs to be done, and I'm going to use the tools that I have to get where it is that I need to go. Okay? So whether it's the addition property of equality or subtraction property of equality or the transitive property or side angle side congruency or corresponding parts of congruent triangles are congruent. All of those things are tools that help get the job done. Okay? And the more of them that you know, the more jobs you can do. Okay? Lesson 29. Using the Pythagorean theorem. How many of us know what the Pythagorean theorem is? We've used it. Should be about every hand in here. Maddie, are you familiar with the Pythagorean theorem? Maybe. Michael, will you tell Maddie what the Pythagorean theorem is? Okay, what is p squared representing in that equation? The hypotenuse of what? Of a right triangle. How do I identify the hypotenuse of a right triangle? I can identify it two different ways. Can they tell me what one way to identify the hypotenuse is? Yeah, but I can orient a triangle anyway so that any side looks like it's slanted. That's perfect. It is the side opposite the right angle. Now, if they showed me a triangle and it looked like a right triangle, but I had to prove it was a right triangle, and they gave me 3 side lengths, which side length would potentially represent the hypotenuse? The longest side. So the hypotenuse is always the longest side of a right triangle. Okay? All right, so looking at this, when the side lengths of a right triangle are non-zero whole numbers that satisfy the Pythagorean theorem, they form what we call a Pythagorean triple. Okay, so whenever I have 3 non-zero whole numbers, not decimals, not fractions, not radicals, right, when they are 3 whole numbers that satisfy the Pythagorean theorem, meaning whenever I plug the 2 smaller sides in for A and B, I square them, they equal the square of the longest side. Okay? That's a Pythagorean triple. So in this program, I can't really do squareds very well, so I use the caret symbol. So a Pythagorean triple is a set of 3 non-zero whole numbers such that A, B, and C come out here. So a better way of looking at this is A squared plus B squared equals C squared. Is anybody aware of any Pythagorean triples? No? Okay, well, we're going to see some here in a second. Okay? Now, you wouldn't necessarily, I don't know if you've ever thought about how this could be used in real life, but I was building a boat dock with my brother. And you know, and here I don't think I was a math teacher yet. I think I was going to school at the time. But we were building this boat dock, and we wanted to make sure that the corners were square on it. And if we could get at least one corner square, the rest of it would end up fitting itself square, right? If we could get, and then we would check the others, and we would kind of, you know, but if you build a box out of wood, there's a chance that it's going to go, right? It's going to get even just a little bit slanted. And so he did this. I don't know if okay. Imagine here is our box, but it's big, right? It's really big. And so We didn't necessarily have this big long tape measure that we could do this with, but we really didn't need to. In fact, you could do it with a square. But basically what we did is we counted 3 inches here. You know, it could be 3 inches, it could be 3 feet. It didn't matter. It just needed to be 3 as a whole number. And then we counted 4 over here. Whether it was inches or feet didn't really matter. Okay, but it needed to be the same unit on both. And then what we needed to have happen is we needed the length from that point to this point to be 5. Because 3 squared plus 4 squared equals 5 squared. And if this is 5, that makes that a right angle. Okay? Does that make sense? So we didn't need to measure all the way across. We didn't need to make, this or anything like that because we didn't have enough tape. But if we measured right from this corner and right from the other corner, and then we could stretch that line across, and you know what? It took a little bit of maneuvering to get it so that it was exactly 5 across there. But once we did, we knew we had a right angle. Does that make sense? That you can see, and that would be my example of if I was going to make an essay for this question, I would say building a boat dock, and I would go into extreme detail. We went from a corner, we measured maybe even 15 inches, we'll see here in a second, or in 6 inches, and then measured across, and then tried to push that into the point where my length between those 2 points, hey, Jose, can we get on something that we're supposed to be on? Okay? All right. All right. So, now granted, got some typos in here that we can fix, but 2 of the most well-known of the Pythagorean triples are a 3, 4, 5 right triangle. Okay? If I know it's a right triangle and I know one acute or one short side is 3 and I know the other short side is 4, I know that the other side is 5. Okay? Another Pythagorean triple is 5, 12, and 13. 5 squared is 25. 12 squared is 144. You add those up, you get 169. The square root of 169 is 13. So a 5, 12, 13 works as a Pythagorean triple. We all awake? Am I bored you to almost asleep, Maddie? No, not quite. So an easy way to find Pythagorean triples is to take like a 3, 4, 5 or 5, 12, 13 and multiply all of those numbers by the same number. All right, so for instance, if I take a 3, 4, 5 and I multiply each of those numbers by 2, I'm going to get a 6, 8, 10. A 6, 8, 10 is a Pythagorean triple. 6 squared plus 8 squared, we got 36, plus 64 is 100, right? The square root of 100 is 10, so a 6, 8, 10 is a Pythagorean triple. Right? You could do the same thing up here. So you would know that another Pythagorean triple would be 10, 24, 26, right? Because all it is it's 5, 12, and 13 multiplied by 2. So do we understand how we could find some Pythagorean triples or identify something as a Pythagorean triple? And you could keep going with it. So like a 9, 12, 15, right? Is all of those, is it 3, 4, 5 multiplied by 3? Those are going to be a Pythagorean triple. Now, the truth is, though, is that not all right triangles are composed of side lengths that are non-zero whole numbers. In such cases, one or more side lengths may be written as a radical expression. A radical expression is any expression that contains a root. Typically, a radical expression should be reduced to a simplified radical form. Let's talk for just a second about simplifying a radical. How many of you are familiar with how to simplify radicals? Somewhat, some of us. Okay. All right, so, gosh, let's take a number like 84. Okay? Okay, so let's say we had the square root of 84. Okay, that's not in simplified radical form. So what I'm going to do is we're going to take 84 and we're going to break it down into primes. Okay, and because this is a square root, we're going to look for pairs of 2s, or 2 of a number. So we can divide 84 by what? 2, right? 84 divided by 2 is going to be what, 42? 42. Okay, 42, we can divide that by 2, and that would give us, what, 21? All right, can we divide 21 by anything? 3, and, okay. So we do have one set of 2, okay, which means that's going to come out as 1, 2. Okay. 2 square root of 21. Oh, I'm sorry, not 27, but 21. Okay? Yeah. When we're done. Okay? Do we understand this? And we could work with different numbers and break it down into a lot of different things. Okay? And let's see, I do want you to understand this just so that we've touched on it. But let's say that we're looking for a cube root. Okay, we wanted to simplify a cube root of something. Like, let's say you wanted the cube root of 125. Okay, so 125, we're no longer looking for sets of 2, we're looking for sets of 3. So that would be what, 5 and 25? 5 and 5. So the cube root of 125 is 5, right? So one set, because there's 3, they come out as one single 5. Okay? Let's see. Let's look at some questions here. All right, Maddie, what is the included angle of DC, that line, and BC? What is the included angle? So you're saying that this angle is the included angle. Okay, do you still have your notes pulled up? Go back to the early part and read the definition for included angle. So this would be lesson 20, was it 28? Read some of the, it should be the very first page of the notes from today. The angle formed by two adjacent sides, right? Okay. So based upon that definition, would you change your answer? Okay, let me bring back our triangle, right? Okay, so if this was my side and this was my side, right, wasn't this my included angle? Yeah? Okay, so based upon that, which angle over here on our left is our included angle? Angle C, okay? Good. All right, we're all on board there. Get that? Okay. All right, let's try another one. Let's see, we are going to skip this question for now. Okay, number 3, what additional information would we need to prove that these two triangles are congruent using the side angle side postulate? Michael, what do you think? They tell me that CB is congruent to CD, right? That's the additional information we need. They're telling me that. I already have that. What additional information would we need? Well, let's look at what else we already know, right? Do we, in a side angle side, right? How much of this do we already know? Do we know a side yet? Yeah. Yeah, we've already got a side taken care of. That's right here. These sides are congruent. Okay? Do we know about any other sides that are congruent between the two triangles? Katie? Was it? Is there any indication that BA is congruent to DA? No. What's the other side though? What other side is there besides, let's see, if you look at triangle ABC, we know side BC is congruent to CD. We can't prove that side BA is congruent to DA. What's the other side, Michael? And how do we know that? It's reflexive, right? CA is congruent to CA, right? Because they're the same line, right? So we can do that. Okay, but if I have two sides, right? We've got this guy here, right? Now I need to use side angle side. Do I get to use whatever angle I want? Like, can I use side angle side if I'm proving that angle B is congruent to angle D? No, that wouldn't be side angle side, would it? Okay. So I need the included angle, correct? What's the included angle, Jose? Yeah, but we can't call it C because C represents more than one point. So can we be more specific? Angle what? Yeah, well, that's the whole thing, but I want the individual angle congruent to the other individual angle of the other triangle. Okay, so let's say this angle right here. Can you tell me what would we call that angle using three points? Okay. B. Okay. Then what? C. Then, huh? No. I got to go this way. Okay? To make that angle, I have got to start here, go to there, come here. Okay? So, angle BCA. Okay? Now, how do I label this angle? DCA. Good. Now, in this case, they use ACB and ACD, right? But that's the angle, that's the thing that I would need to know because I already know about two of the sides, but I would have to somehow get the information here to prove that those two triangles are congruent using side angle side. Okay? All right. Here they tell me that P is a midpoint. Okay, P is a midpoint. What does a midpoint do to a line segment? Marcos, what does a midpoint do to a line segment? Represents the middle, yes. What do I know about either side of a line segment based upon a midpoint? Well, I don't know how far they are. I do know one thing, though. No, I may not know that. Well, we're not talking about angles. We're just talking about line segments. Makes both sides from the midpoint, right? If this is the midpoint of the room, what do I know about from here to that wall and here to that? They're the same distance. So a midpoint divides a segment into two congruent segments, correct? Okay. So they tell me that P is the midpoint of TQ and RS. TP is congruent to QP. And RP is congruent to SP. Does anybody know what our reason for that is? Well, let's look down at some possible reasons. Definition of a midpoint. That's the only possible one, right? Definition of a midpoint. Because that's what a midpoint does, is it divides a segment into two congruent segments. All right? Now they say vertical angle theorem. What do we know about vertical angles, Chandler? What do you know about vertical angles? They are. That's a good way to start it. They are something. Vertical angles are what? Okay, that's like, what are cars? And you wrote a sentence that said, they are cars. All right, you haven't said anything. What are vertical angles? Can anybody help him out? They're, well, sometimes they're side to side. Vertical, and when we covered this, I said you need to know this, because I will ask you and I will get really frustrated when we don't know this and we still don't know it. Vertical angles are, write it down, type it up, put a highlighter over it, put an asterisk next to it, put little blinky lights next to it. Vertical angles are congruent. They're equal to each other. Okay? So they tell me vertical angle theorems. All right, so I have side and side, just like we had in the other question, right? What are the vertical angles that I want to be congruent so that I can use side angle side congruency postulate? Katie, can you name the two vertical angles? Okay, this is just like what I asked Jose. We need to name them using 3 letters. No, SPR is a line. I need 2 angles that are vertical to each other. TPR. Now we're going to get this. TPR and SPQ. So angle TPR congruent to SPQ. And then our last one is going to be side angle side congruency postulate. Okay, you guys can go.